very excited, as I mentioned, that you're joining us this evening for the Aerospace Engineering Virtual Academic Session. We, of course, wish that we could be meeting with you in person, but unfortunately, that is not the case. I think this is a really great opportunity, though, because you can also ask lots of questions with us tonight through the chat feature. So we hope you'll take advantage of that. So just a reminder, it's a Q&A presentation. We have a brief presentation that we'll do and then options to ask questions. We are using Zoom. We can't see you, we can't hear you, but you can see us, which is really helpful. We are also recording this. So just in case you want to go back and see what information was shared or you missed something, you can definitely come back in about a week or so. It'll be available on our website. So I want to mention too, I'm going to turn this over to our presenter in just a moment. I'm going to turn my video off, but I will be monitoring the questions that come through and any that I can answer that are general about WPI or admissions. I'm happy to do so. But otherwise, I'm going to save some of the aerospace questions for our expert. Sound good? So I'm going to turn it over to Professor Gatsanis, who's going to kick us off with the presentation.
Thank you, Julie. Good evening, everybody. I hope I will make this entertaining and also informative. As Julie mentioned, it's going to be relatively short, so make sure you keep notes and ask your questions. You know, this is it's an opportunity for you to have all your questions answered. So I'm Professor Gatsanis. I'm the department head of the Aerospace Engineering Department at WPI. And I'd like to spend a minute in this first screenshot here, my first slide, because it shows WPI. What we have here on the top is one of our vacuum chambers where we do space technology. We test space technology. Professor Blandino is here. And with one of our former students who is now faculty with us. And to the left, you know, these are systems that we build, our students build for our projects, the major qualifying project at WPI. A rocket here, a vehicle we took into the SAA competition. Another one here, again, in one of the nationwide student competitions where we go there and a lot of students participate, and usually we're doing extremely well. Then here on the bottom, this is a small spacecraft. I'm sure a lot of you have heard about CubeSats and nanosats, very tiny spacecraft. And we do a lot of work on nanosats in the aerospace department here as well. Here on the top is another propulsion device. It's a system that we use for spacecraft propulsion. And here, these are members of our rocket club. We have the most active club on campus, the IAA, American Institute of Aeronautics and Astronautics Club, mostly with aerospace engineering students, but students from other majors too. And they do a lot of activities, including a rocket activity. And of course, I could not include Robert Goddard, who had, of course, an affiliation with WPI, and you see his little rocket here. And if you ever come to campus, which I hope you do, we have a picture of the original replica of the rocket as you enter the department. So this is us. This is aerospace engineering at WPI, and I'll take some time to get you over the program and the specifics. But before I do that, I want to make sure that everybody here is for the right reason, okay? And what I mean with that, you need to like certain systems if you are to get into aerospace engineering. And the systems come in different sizes and there are different types, but let's start first of all, you need to like aircraft, right? And by like mean you need to like to be involved in the research, the design, development, testing, or construction of this kind of vehicles. And you see, this is what we do as aerospace engineers, aircraft of all kinds of sizes, right? And utilization for commercial applications, civilian applications, also aircraft for defense applications. Again, very different, right? I show you here the vast difference in not only size, but also functionality of this spacecraft, of this aircraft. So you can imagine what goes into them. We're also involved in rotorcraft for civilian and defense applications. Again, very different in type, right? And size and functionality, obviously. We're also are involved with the UAVs. You know, most of you are familiar with UAVs, drones, we call them again. We use them for different applications here. I include also here a Spirit one, which is produced right here in Massachusetts by a company with which we do business together. We do research. Again, all kinds of different drones. And so these are things that systems that we aerospace engineers are involved with. And then we're going to launch vehicles. I'm sure you're watching SpaceX and all the marvels of launching vehicles lately, which is great. And this is where we come in handy as well, right? And we do also missiles for defense applications, not just delivery vehicles. And finally, we're involved in spacecraft. A lot of you are now fascinated with space, so am I. And we do, aerospace engineers are involved in spacecraft design, construction, research. And again, spacecrafts go from the very large ones, as the one I saw you here with tens of meters of solar arrays, all the way down to these tiny ones, the nanosats that I mentioned before, which are becoming a lot more prominent in space. So that's what we do in aerospace engineering, okay? So we have a baseline. Now, the industry that supports us is vast in the United States. In support of this industry, which employs millions of people and is a net producer of, in terms of wealth. We are a major exporter, one of the only the one manufacturing industry we have, which is a net positive exporter. And this industry is supported by the network of universities that produce bachelor's degrees, master's degrees, and PhD degrees. I have here a number which will give you a relative sense of scale of aerospace engineering in the United States. These are data from 1718. We have newer data, obviously, but these are produced by SCE, so they tend to, you know, they have to wait for a few years until they finalize the numbers. But you need to have in mind that if you earn a bachelor's degree in aerospace engineering, you'll be among 4,000, probably 4,500 other individuals with a degree. So it's a cohort which is unique and small, relatively small. And we also award about 1,600 master's degrees and about 400 degrees, PhD degrees. So that's the aerospace engineering degrees in the country. Now, if you are to compare with mechanical engineering or chemical engineering, these are tens of thousands, right, of bachelor degrees and similar scale in master's and PhD. So we are a cohort which is smaller relative to other engineering degrees. And also as departments in the country, we have about 70 programs that give bachelor's of science degrees. So that's what you are looking at. Now, an overview of our department at WPI. We are the 6th largest major at WPI. We're quite popular. Obviously, we have about 330, I would say now, undergraduate students, more than 30 students, graduate students, PhDs. And then we have a lot of students who are in the BSMS program, the 5-year program. So some of those now are classified as undergrad, some as graduate students. Now you see the numbers since our inception of the program of the BS degree in 2004. So it's growing and will probably stay at around 70 to 80 degrees per year, right? But PS degrees per year. So that's the size that you need to keep in mind. The faculty in aerospace engineering, we are 10, all of us aerospace engineers dedicated to the program. We only teach and do research related to aerospace engineering. We are all invested in research and we are involved in MQPs and projects and teaching. So it's a holistic program where we're all hands-on with education. The department has a good set of laboratories, which we constantly improve and upgrade. And I'm just going to go and show you just briefly some of the facilities we have available for our undergraduate education. Some of these labs are also research laboratories. By the WPI, we do engage undergraduates in our research. So a lot of times you will find PhD students and postdocs working next to each other with undergraduate students. So We don't have segregated laboratories based on what degrees our students are pursuing. So you see here to the left, aerodynamic test facilities. These are in the basement of our building. If you come to campus, we're in Higgins Laboratory. So in the basement, we have some of these heavy apparatus. Then we have vacuum chambers where we do work on spacecraft propulsion, other space systems. We test basically our systems in vacuum in space. We have laboratories for aerospace structures and materials, very unique materials that we use for aircraft and spacecraft, obviously. We have a combustion laboratory. We have a laboratory, it's called Discovery Lab, where we do experimentation. This is the lab where our undergraduates mostly use for their undergraduate courses, all of our undergraduate courses, right? Or most of them in every sector that we have in any curriculum area, they have an associated laboratory, and that's where we do our laboratory. Then again, we have more wind tunnels, and we have laboratories for autonomy, as you see here, some of the drones that I mentioned before. We have also a laboratory where this is the MQP. MQP is the major qualifying project, the project that all of our seniors do at WPI. It's a long commitment. It's equivalent to 3 courses, one of the hallmarks of WPI education. And we have a space dedicated for this facility, although we do a lot of our MQPs also in our research laboratories. But when we design these systems that I mentioned before, aircraft or rockets, this is where we do them. And then we do also MQPs within our research laboratory. So that's where where you're going to see hands-on experience. Now I'm going to spend a few minutes with the structure of the curriculum at WPI. And just to get things going, at WPI, we use a unique system. First of all, our terms are 7-week terms. So they're not quarters, they're not semesters, but 7 weeks. And classes meet daily, okay? So that's a big differentiator from other places. And now we have 4 of these terms per year, and then we have also 2 terms in the summer. Now, we also use units to describe our courses. And a typical 7-week course is equivalent to 1/3 units. 1/3 units is equivalent to 3 credit hours in most other universities. So that's the equivalence you need to have in mind. I'm going to talk mostly about credits. So if you're using credits, that's probably easier. But when if you join WPI, then units will be the common currency we do. And then a typical load for a student is 9 credit hours per term, or 3 courses equivalent. And I'm going to show you a typical program. So how are these credits split, and what kind of general areas a student pursues the WPI? First of all, WPI has requirements as every other school, which apply to all engineering students. Now, these requirements call for 36 credits in what we refer to as general education activities, and they include humanities, social sciences, physical education, and also the interactive qualifying project. This is the IQP, one of the major projects that students do at WPI. If you're serious in looking at WPI, then you definitely need to look into our projects program. And I'll talk a little bit about the IQP, but I'm sure you're going to have a chance to hear and see more about that in your quest for information at WPI. So these are 36 credit hours that all engineers have to undergo. We then have 9 credit hours of free electives, and these are electives that students use for minors or double majors. Okay, so these are free, and we don't have any kind of other than suggestions, right? Through our advising students who want to opt for certain minors or majors, then they fill in with these free electives. Then we have 10 units of math and basic science. And math includes calculus, the calculus sequence. Some of you will come with AP credits, so you're going to knock off some of those courses. We have courses in physics that you need to take, and again, AP physics may take care of some of those. And then chemistry, which has also laboratories, and these physics courses, obviously, they have a lot of laboratories, a lot of hands-on experience there as well. And we have also a course that we offer with the physics department on atmospheric and space environment. So this is unique to aerospace engineers. Of course, others can take it, but all aerospace engineers take this course. So these are the general distribution requirements that apply to most aerospace engineers. And then here we are, you becoming a rocket science, okay? So here now we have 20 third units. These are 60 credit hours of engineering, science, and design. And these are now all devoted to aerospace engineering. We have two tracks in aerospace engineering, and each track has a unique list of courses. But you see here, right, courses in aerodynamics, aerospace materials, aerospace structures, propulsion, flight mechanics, everything that makes an airplane or a rotorcraft fly. And the same is true for this astro track, right? Orbital mechanics, control, telecommunications, space structures, rocket propulsion, again, things that are related mostly to spacecraft, rocket launch vehicles, missiles, etc. Right? They may fall in both categories, but these are the kind of courses you are going to take as an aerospace engineer. Then our students dip into other areas, and then they spend 12 credit hours in what we call design experience, major design experience. And that includes a course which is either aircraft design or spacecraft design, where you learn now at the system level how to design a specific aerospace system. And then you do your MQP, which is the aerospace design project. This is the major qualifying project equivalent to three courses, long project, right? I'm going to show you some examples. And again, students work in groups there and design systems or subsystems that go to either aircraft, rotorcraft, drones, or spacecraft. So that's the sequence of courses that you take. And here I have a program, right? A sample program that interfaces also with a 5-year program. I'm going to spend a few minutes about it. But you see that at WPI, 4 years actually are not necessary to finish a bachelor's degree. We need 15 terms in order to fill up a bachelor's degree. And then if you come with AP credits, this becomes another opening here. So you realize that you can use these openings in order to do majors, double major, minor, or pursue the BSMS program, which a lot of students finish in less than 5 years, actually, because they take advantage from this from the opportunities we have, right, with AP credits and the structure of our curriculum. Very briefly on NQPs, I mentioned that these are done in teams. These are the senior projects. We do them in our laboratories. A lot of times we do them also with national laboratories, research companies, and our students design systems, rockets, for example, right, that do special things, right, not the kind of toy rockets that some of you maybe used, or they design special UAVs, right, or systems, autonomous systems. Then we do software design primarily, but complete design of CubeSats. We cooperate with Goddard, for example, on some of these missions. Then we do drones, etc. Our students go take these designs and go to competitions. They go to the IAA regional conference, and they do extremely well there, right? We are very, they're very well trained, and they do very well. They participate also in other competitions, national competitions. I mentioned the SAE competition, for example. We also participate in the IAA, the design, build, and fly competition. Now, students also in our department have opportunities to join and start doing things with clubs. I mentioned the IAA club, one of the most active at the WPI. This IAA club has groups, and they're involved in different activities. They're involved in rocketry, they're involved in CubeSat design. Also in some of our projects, the DBF, for example, the design, fly, build project, we do involve juniors, right, and sophomores in the senior project. So we try to build this community from earlier on with our IAA club, of course, when they start taking courses, and then with these hands-on opportunities that we offer them. So it's a nice community, and students know each other and learn from each other, and they pass also experience, right? The seniors, right, to first-year students, juniors, etc. We have also a lot of opportunities. A lot of times I get this question: what kind of research opportunities do you offer on campus? And we have a lot of those. First of all, we have programs that we run through NASA. Space, for example, is a program like that. SOAR. These are summer opportunities in aerospace research. And every summer, we do engage several of our undergraduates who come and join research in our laboratories. A lot of our students also pursue research in companies through internships. Also, they do work at NASA centers. You know, I have here some examples of them, right? These are students of ours who went to Wallops. So there are plenty of opportunities for those who want to pursue them. And these opportunities are available at junior, sophomore year. As they go up in ranks, obviously they have more and more of those, but we do have a lot both on campus and around the country. Now, very briefly on our BSMS program. This is very popular. Obviously, I'm going to share with you some data, salary data. In 5 years, and less than 5 years in many cases, students are at a master's degree, they have different career paths, and we have it in a seamless way. It's integrated with the undergraduate program. It's a very simple, there's no real application. It's a process where students declare that they want to go into the BSMS program. So it's not a readmission, right, to the MS program. And as I mentioned, almost half of our graduating class pursues this 5-year program. There are a lot of benefits also financially to do this program. So you're going to keep that in mind while you're searching for schools and opportunities, and you keep that in mind when you put check marks, right, in choice of school universities. Now, the last few minutes, I'm going to spend it on career development. So let's say you enjoyed our program and you joined, and now you're about to graduate. So I have a list of companies that have hired and are graduates, and I'm going to let you browse through it, right? So you can recognize companies, large companies like Lockheed Martin, for example, that you see there, or Northrop Grumman, or Pratt & Whitney, right? Raytheon. So these are all companies you can recognize, British Aerospace, but also smaller ones, right? So our students are everywhere practically, right? Large and small companies, from startups to giants, we have them there, right? And the list continues on, as you see here. SpaceX, again, right here, the companies that you are known, Sikorsky Aircraft. We have very, very good placement. A lot of our students also are employed by non-aerospace and defense companies. And you can see that Amazon, for example, right? They hire aerospace students, of course, right? All their work with drones, etc. And other companies as well. Also government laboratories, you see here. Our students are everywhere. And then graduate schools, obviously, a lot of our students pursue a master's, PhD in other universities. So all of these are options. Those who want to go and earn money right away, they can do it. Those who want to pursue advanced degrees, they can do it at WPI or elsewhere. And of course, you know, the BSMS, as I mentioned, offer another vehicle for masters, right, in a faster way. And here I have some employment data. So you see that the numbers are corroborating what I'm saying. First of all, I want you to look into the success rate of our employment. So 90s here, obviously 2020 was not a normal year, right, with COVID. We're waiting for 2021 data. We know they're much better than the 2020. Our CDC, our center that processes usually processes them around this time, right, late September, October. So when you check later on, you'll be able to see the data as well, the 2021 data. So you see, I would say 70s, right? 70s to mid 70s as average salary for BS. And then again, this is our success rate. Those who return, right, information. That's how we base this rate. So again, in case of a master's, you add about $10,000 to the starting salary. So that corroborates the fact that indeed, you know, our program is robust, our placement is very robust, and you know, once you work through this program, obviously you have opportunities for employment and or opportunities to further your education. We have a lot of other information available. Julie mentioned this will be recorded. We have also other information available on some WPI sites. And you can see some videos also with some of our faculty there introducing their laboratories. So you're welcome to browse through those. So I'm going to stop here and thank you for your attention. Julie will start working on your Q&A now. So let's do that and make sure we answer all of your questions.
Yeah, so a couple of questions came in sort of as you were presenting, and I think some details might have been ironed out, but there was a question about the first year, whether or not it was more general education, what students are looking at. So I know you had a really good graph of
Yes.
courses.
So
And I think
first year, this is a typical first year, and I can go through the courses of a first year student. This is math, the calculus sequence. And then we have the physics sequence and the chemistry sequence. And then this is humanities. We just put it there. I haven't seen two students who had the same schedule in my entire 20 plus or whatever years WPI. So each one is a unique student, and you're going to have an advisor, and you're going to work with your advisor to draft this program, your schedule. And those of you who come with AP credits, obviously you're not going to follow that. So you're going to start taking engineering courses from very first on. But for a typical program where where this typical student here has not taken any AP courses, this typical student will start taking engineering courses in D term of the first year. This is ES 2001. This is Intro to Materials. And then, of course, sophomore on, that's it, right? Then you blend with aerospace starting from first term and on, then you become a rocket scientist. Those with AP credits, obviously, you're going to start taking courses, engineering courses, right from the first year.
yeah. And it's very common for students to bring AP credit, especially in the calc sequence. That's the most popular this year. It was a little different. I think students were a lot more cautious about using that AP calc credit. But in a non-pandemic year, on average, first-year students are starting with Calc 3. So you can imagine how much of a window that opens up for students for what all else they can take. And then similarly, we offer credit for things like Chem 1010 for AP chemistry and AP physics if it's calculus-based, right? And then some of those social sciences that you see on there. So the SSPS, you're able to put one AP credit towards that. So if you take an econ or sociology or psychology, and then the humanity and arts, you're also able to put one of your AP credits for humanity and arts to it. So lots of flexibility, which I think is really important to know.
Which is very important. WPI prides in more in less. And we do make this happen with AP credits. And so really, people can graduate, right, in 3 years at WPI, right?
Right. Happens a lot. One quick question, in general, class sizes for first-year students?
Yes.
I don't know if this is referring to aerospace specifically or kind of all of the classes. I don't know if you want to speak to the classes.
Yes, I can talk about the aerospace engineering classes. The math and physics, they are well populated. But again, for example, our physics courses, they have laboratories, which are, right, they may run a class which has a lot of students in the classroom, but then the laboratories are in smaller groups. And same is with chemistry. So you have a lot, it's unfair to say you're in a class of 90, for example, in physics, because of the laboratory components of these courses. Also, our math courses, they have a lot of laboratories associated with them. Right now, the aerospace engineering courses, for example, 2712, this is Intro to Structures. You may have 60 students there, right? It's our entry class. So our entry classes start with 60, 70, depending on the incoming cohort. Then as we go on to later years, right, you may take classes with 20, 25, or 30 as we split, right? Again, our classes also that have these numbers, we also have laboratories where you are in smaller groups. So it's a different, you cannot compare with the typical school where, everything is in the large classroom. We have a lot of individualized one-to-one education also WPI. For example, the projects. You do 2 projects equivalent to 6 courses. Well, in these projects where you have one or two faculty associated with you. You're going to be in groups of 3, 4, 5, or 6 students. So you need to put all of this together, right, to get the full picture of class size at WPI. So it's a very unfair comparison with other universities where they don't have the project-based education.
And speaking about the projects, one of the questions is, what are some of the MQPs that students have done? What are some examples of those?
Okay, I have some of them here. This was a model rocket. That was a high-power rocket model that had a lot of technology in it, deployable fins, other things. So that's why I said these are not the toy rockets that some of you may have used, right, or may participated. Also, this is another, this is an MAV, micro area vehicle, specifically for the SAE competition. These are designed with, SAE is a national competition, right? So we participate and they provide every year around this time, the designs for the year. So our students this year, about 10 of them, they're designing for the SAE of 2021, right? So that's another project. This is another project, that's a CubeSat. It's a CubeSat, it's a 4U CubeSat here, specifically with propulsion, etc. So again, that's an MQP project. And another one with drones. So these are the type of projects that we typically do, right? And some of them have 5 students, some 10, some somewhere in between. So it depends on the project, right? And this is just a sample.
Okay. Let's see. This is a good question. How would you characterize a student who would thrive at WPI Aerospace program?
In terms of personality, or how would I, can you repeat that, Julie?
It was, how would you characterize a student that would thrive at WPI in aerospace engineering?
Oh, I see. Okay, great.
Yeah.
Well, students at WPI, they have to be self-motivated, right? And they have to be ready to do open-ended projects. So our education, our curriculum is based on a lot of self-learning. And that's why also, our credit hours, the way we've structured them, they require a lot of out of classroom studying, right? So you need to be self-driven. And look, you need to be interested to look out of the box. Also, the curriculum at WPI offers a lot of flexibility, right? We have these blocks that we have, but students do minors, right? They do double majors, as I mentioned. So they have to have this entrepreneurial spirit in education and other aspects of engineering. So I guess this will be the those who would thrive at WPI.
Yeah, I see the same. And that's what I say to a lot of students I meet with. It's kind of a blend of being smart, right? That's really important, enjoying STEM and excelling in those areas, but also we're looking for students that are very collaborative, can communicate with other humans, are excited to be innovative and solve problems and do this project work. And that's unique to WPI. So from an admissions perspective, our committee is specifically looking for students that can help us see that through their application. So think of that when you're completing your application too. Question about double majoring between aerospace and mechanical engineering and what that would look like.
Okay, usually what we suggest for our students when they double major is to double major with something that is, for example, electrical engineering or computer science or robotics engineering or chemical engineering, not necessarily mechanical engineering. Now, you could do a minor in mechanical engineering if you wish, or minor again in electrical, computer. So we suggest that our students do a minor or major in something which is uniquely different from aerospace engineering, right? And mechanical obviously is in its own subject, but with a degree in aerospace engineering, we can target every mechanical engineering job that is available. So you're not limited by the aerospace engineering degree. But if you do a double major in electrical engineering, for example, or a minor electrical engineering, computer science, you add value to your degree. So that's the view that you need to look. Mechanical is very different subject from aerospace. But again, in terms of job prospects, you're not limiting yourselves to aerospace engineering, right? By a BS in aero. you can target all the ME jobs as well. The opposite is not the same, however, right? Because of the very unique knowledge that you get in Aero. So it doesn't work the other way around.
This is a good question. Someone's saying, you may have already covered this, but could you talk about the hands-on and laboratory opportunities for aerospace? And specifically, can you talk about the facilities and the infrastructure to support?
Yes. I showed here some of the laboratories, right, where we do projects, but I'm going to go to our classes here. I'm going to show you which classes have laboratory components. For example, 2712, the Intro to Aerospace Structures, has a laboratory component. 2713 is our astronautics. It has a lab component, but it has a lab component which is a computational laboratory component. We teach our students laboratory, both hands-on, right, but also computational skills and data science skills. Then we go to 3602. This is our incompressible fluids course. It has a lab component. 3713, it's our aerospace structure course. It has a lab component. So 3711, our aerodynamics course, it has a lab component. Then, so all of our courses, right, materials, GNC, our guidance, navigation, communication, they do things that have to do with guidance, navigation. Then when our students do our MQPs, they of course, it's all hands-on, but before we do them, we take them all through a series of software, which involve ANSYS software, COMSOL. They learn how to use design, thermal design, heat transfer design. We also train them, we give them certificate to a software which is called STK. This is the major software in aerospace industry. I don't think any other school in the country does this. And our students get certificates on that software that does spacecraft design and mission design. So our students get education, not in only the traditional laboratory sense, where, right, you do the traditional lab, but they have also computational laboratories, and they gain both in data analysis, data science, associated with the discipline. So it's a holistic approach we have. And as I mentioned, we do upgrade our labs constantly. And especially now we are a department, we are a new department, probably I forgot to mention that as of 2020, we're an independent department. So we have now more, enhanced ability to do this kind of insertions and upgrades in the program. So the answer is yes, we have a lot of laboratories, and we do plan to have more as we go into the future.
Yeah, and I think in terms of support for our students, across the board, something that WPI really shines with is the advising network and the focus on undergraduate education, the opportunities to connect with faculty really early and often. Faculty, by and large, have open office hours. If I have a question about aerospace and I can't answer it, I know I can walk 2 buildings over and just walk into the space and say, I need some help. Who can answer some questions? It's a very welcoming environment in that measure because, all of us are just trying to help each other out throughout a student education. And then we have some really fantastic support services for students kind of just beyond their major, their career focus in terms of our academic advising, our accessibility services, or our student development counseling center. There are a lot of places that students can go, and a lot of folks checking in on them too to make sure that they're doing okay. So I did want to mention that in terms of support.
And just to add to what Julie just mentioned, in our courses, for example, we have teaching assistants, right? But we also have what we call PLAs, peer learning assistants. And we have, in almost all of our courses, we have deployed PLAs. These are undergraduates, seniors or BSMS students. So they are the ones who are the boots on the ground, and they help one-to-one our students in classes. And think about them. You are an aerospace engineering student who have taken a course, you know a lot, right? About the details, etc. So we have this network that Julie mentioned, and that forms also the community that we have.
So a couple more questions, and I know we do have to wrap it up in the next few minutes. So one thing I wanted to mention really quickly is there's somebody asking about reaching out to current students at WPI that are majoring in aerospace. You can always email us in the admissions office at admissions@wpi.edu. We have a bazillion tour guides that are looking for ways to connect and happy to answer questions. Similarly, I know Professor Katsanis would be happy to match you up with someone. So if you wanted to reach out directly to the department, same deal. Our students love to talk about what they do. So that is definitely an easy.
We're going to post also, Julie, I'm going to have our AAA Club record a video. They have started doing it. So we're going to post some of these videos of, we have 3 clubs, Sigma Gamma Tau, which is the Honor Society, the Women in Aerospace and Engineering War, and AAA. So all 3 will post short videos so you can take a glimpse in those as well.
That's very, very cool. Someone's asking real quick about, is there a type of computer you'd recommend?
Not really, you know, we are computer agnostic. We love all computers. The WPI campus is mostly a Windows campus. So most of the software, and there is a ton of software that you'll be able to, but you know, look, my daughter always loved her Apple computer, and she did perfectly okay too. So
yeah. And two final questions. One, types of jobs common for recent graduates of BS or MS. I know you touched upon some recent employers, and there's a lot of information in the career outcomes that Professor Gatsanis mentioned. We have that on our Career Development Center website through 2020 and 2021. Any day now, as he mentioned, is going to be available too.
Correct. And this presentation is available, so you can see there's, I don't think we're missing any aerospace company in the US, you know. I mean, we have graduates there, right? So feel free to browse through our list. It's a very comprehensive list and impressive. So,
and my favorite final question, because I get asked this quite a bit, do you offer classes towards a pilot license or a minor? We get a lot of flyers that are
I know
that join WPI, that work at WPI.
Yes, I know we don't, but we have airfields very close to Worcester where students can do that. So there are many options available in Massachusetts, and Massachusetts is a small state. So, you know, you can do that, but we're not involved in that. We're not an aviation school, as you know, and we don't have any affiliation with any of these facilities, but there are plenty around. And I had a lot of my students who are pilots, both current students and former students, both graduate and undergraduate. So,
and a lot of faculty.
Yes. Yeah.
Definitely.
I know that too.
Yeah. Well, thank you all so much. We're right at time at 7:45. I do want to mention, again, if you have any questions, you can always reach out to us at admissions@wpi.edu. I am always happy to forward questions to Professor Gatsanis about aerospace. If I can't answer them, or if you want to speak to a student. The other thing I do want to mention is Professor Gatsanis mentioned, you know, we have a lot of opportunities to connect with us online as well as in person. We are offering in-person tours and information sessions just on a smaller scale, but pretty much every day, including Saturdays. So definitely check out that online. It's www.wpi.edu/visit. So super easy. And then virtual academic sessions for lots of other programs you might be thinking about. Also undecided. We have an Ask the Deans session coming up in the coming weeks, and general information sessions and tours online as well. So any way you want to learn a little bit more about WPI, we definitely encourage you to do that. But thank you so much for joining us. We hope to actually.
Good luck, everybody. And wish you the best in your studies and your quest for schools. I hope to see you at WPI. Bye. Good night.
Thank you all.
Thank you, Julie. Good night.
Bye.